All right, project 1.
Oh no.
Oh, that was beautiful. Could I get a groan as well or something? No. Oh, yes.
We need the bottle of tears. What do you do with that?
Oh, it's on my desk. It's labeled.
It's still on your desk?
Yeah, it's labeled extra salty. I will treasure that for a long
Extra
time.
salty.
And if it ever gets gross, you can just clean it and put something else. Get some other students.
Well, it's got salt in there, right? So it
So
shouldn't
this is
be.
basically hashing.
Huh?
This is almost as if it's hashing the project.
Yeah, you can try and use a hash table, but it'll fail. All right, map.
Yeah.
Storing and searching keys based on key value pairs is incredibly common in computer science. A lot of times, well, computer science, actually just software engineering in general, you're having a key and you want to get some object back from it. And there are plenty of complex data structures for general purpose key value pairs, but here's the but for this project. If given some constraints, a very efficient one can be created from just using a simple array or simple arrays. So right now you're just using arrays. That's your big hint for this project, because I'm going to constrain it such that it's a lot simple. A lot simpler.
Only arrays.
You can do this with arrays and pointers. I think, all right, first off, with the project, there's more than one good solution. Yes?
What about stacks and queues, since they're based on arrays? Can we use
Sure,
them?
go ahead. You can do whatever you want. There are plenty of good solutions to all these projects.
Not really.
There are plenty
No.
of terrible ones as well. Wait, question or? Okay. Our map shall consist of a student's first and last name as the ID. So that's the first thing that goes in. And then you're mapping it to an ID, and it's mapped to an ID. In other words, we're mapping a string to an integer.
So you like make the combination of the name and it's going to be.
Yeah, like you have,
Got it.
you know,
Are you casting a string to an integer?
no, you're mapping a string to an integer.
So this has to do with objects.
So you may have, John, good old John Doe. Maps.
That's John die.
John die, there you go, 2, 3, 4. All right, that's all. And you're going to do this a lot.
Thank
John
you. Makes so
Guy.
much more sense.
John die.
All right?
Wait, so you have. So the 1, 2, 3, 4 is not actually what the John Doe equals?
That's what you're mapping it to.
Okay.
So you can map it to whatever you want.
In this project, in general, you could, but for this project, we're only mapping strings to integers. That's it.
Oh no, yeah, but like whatever number you want.
Yes, any number, any integer.
Now do you put the integer in there?
So hang on, relax.
I can't relax. Some stress crocheting.
Names shall have first name and last name, both starting with an uppercase letter followed by a lowercase letter. In between each letter and last name shall be a space. All right, that is actually a huge constraint. That's going to help you out a lot. Think about that. You have a first name and a last name with a space in between. All right.
So how we normally write a name?
Right, but it's only going to have letters and a space. You're not doing any wacky characters. No names are going to have dashes. That's taken out. No dashes or any little, what are they called? Accents above the letters. Yes. Do you have a question, Jay, or are you just stretching? Okay, cool. All ID integers will be above 0. So that may help you or may not.
So not
Positive.
there you go.
They're positive. It's not non-negative because it's not 0. It's positive.
Good.
So all IDs are positive.
I was trying to say non-negative.
So we're going to have a class map. We haven't done class too much, but I'm putting this project out now because you need to start thinking about it. Because we'll do classes next semester. Next class. Woo! Oh, that was bad. Public, basically everything's public here. Boolean add, you're adding a character, character array key and the value. So, if I were up in my code, and I were to I create a map, I'll call it lowercase map, puts it on the stack because I didn't do new. And I do map dot add John die. There we go. Is that better?
Yeah.
Yeah.
1, 2, 3, 4. Ooh, that was bad. It's going to add it to the map. Then you can call get. Searches for the key. If found, it sets ret to the correct value and returns true. All right, so this is a little different. Otherwise, this function returns false. So this function is returning a Boolean, tell you if it worked or not. And then ret's going to hold the value. So, in other words, I know, hold on, it's a little weird. Int ID, and then I do map.get John space die, and let's see, ID, and then you put the pointer of ID.
Wait, is that pointer or is that?
Oh, that creates a reference to ID. I can't do the ampersand right now. Wow. How does that thing look?
Any help over there, Chief?
Okay, that's the sound it makes. Boom.
I thought that was used for reference. Or not for reference, for location.
It is. You're passing location of ID into that function.
Okay.
That way, afterwards, when you print ID, you're going to get 1, 2, 3, 4. All right? And this would be true as well. Map.get would have returned true.
I have a question.
Yes.
This goes back to the stack and heap. When is it like conceptually, when is it a good idea to know when to put something on a heap and when?
So you put stuff on the heap when you want it to be persistent for a long time, aka outside of function calls. You put stuff on the stack when you're using something local and temporary, and you just need to mess with it for a little while and then let it be deallocated. So my example, I use the stack. That way I don't have to do new and delete all the time. Okay, does this make sense? Not at all. What are you talking about, crazy man? All right. All right. We want to be able to get the size, memory consumed by this data structure. I'll talk a little bit more about size of and everything next class. We want to be able to remove something from the map and free up any memory it uses. Now, with just those, last semester you learned about hash maps or hash tables, and that would solve the problem actually pretty well. But here's where it gets tricky. Now we want to do how many, return the number of names with a given prefix. Okay, if we have John, Jonathan, Paul, Mark, Luke, Jonah, and then we put how many with J-O, we get 3 because we got John, Jonathan, and Jonah. Okay? Because those are the names that start with J-O.
So, can we do all of this already?
There's a couple of syntax things you don't know about, but conceptually you should be able to solve this in your head.
In our head, okay.
That's why I'm giving it to you now to get you to start thinking about it.
When does it do?
Okay, hold on. When does it due? Should be 3 weeks. February 9th. There we go. All right. Some things to help you out. The crux of this project is determining what your data structure will consist of. Once you figure out what the data structure is for this one, it's real easy. My solution is less than 100 lines.
For all of it?
Yes. But I've seen plenty of good solutions that go up to 500. Just so you know. So if you have 500 lines of code and it works, that's perfectly fine. Mine's pretty short. I have provided a common list of first names and last names. Let me make sure that that is in there. Good. So I can, cat first name, bunch of first names. Looks like they're in reverse order. That's fine. And I can cat last names. Bunch of last names as well. Those are the only names I'm going to use. So if you can glean something important from those names that'll help you, sure, go ahead. But I'm telling you, there's only alpha letters, A through Z, with capitals for the beginning of each word, for each name.
So we don't have to pull names from that file?
To write your test cases, no, you can have your own, but I highly suggest you do.
So we have to know how to pull from the file?
You will. I'll get to that in a moment. If you were to create an array of all possible combinations, it would take up over 4.5 gigabytes of memory. So don't do that.
Isn't that what you want, though?
A list of all possible IDs would be just under a gigabyte, and total about 5.5 gigs of memory, which is not acceptable. So I'm only going to use a subset 1/50th of the total list, but still don't try and generate all the strings. Even with that, it's not going to work. It won't work out very well.
I said don't generate stuff.
Yeah, don't do the naive brute force method. It's going to fail terribly. The main thing to keep in mind is we are storing IDs. In all actuality, we just need to hold IDs. We don't exactly have to hold the string. That's your biggest hint. While the student's name is used to index into the ID, so you need to somehow think of how you can use that student's name in order to index and find the ID. You don't have to necessarily store the student's name. Hopefully I've repeated that enough.
Sure.
How can we efficiently store the names to map to integers, to an integer? It is vital you think about the data structure before starting coding. I suggest drawing out a bunch of pictures if you have problems. You'll be doing a lot of pictures in this class when it comes to your projects. It'll help. Trust me, it'll help a lot. All right, so far we've learned about arrays, pointers. Okay, we haven't learned about linked lists, but they're not necessary for this one. That's enough to design your data structure. No hash maps for this problem, they're not necessary. While a hash map would solve the add remove efficiently, it's going to be a bit tricky for the prefix. You'll be judged on memory footprint as well as your performance of your code. All right, warning. Your data structure projects are significantly more demanding than your labs. I hope you have noticed that just by this description. It's imperative you start thinking about the data structure now. That's why I've written this out now. We'll go into a little more details of how to piece everything together next class. If you hit a roadblock, and you probably all will, and that's perfectly fine, it's imperative you come talk to me. I do expect that pretty much every student is going to hit a roadblock on these projects. If not on this one, on a later one. Just come talk to me. When you come talk to me, tell me what you've thought of so far. Make sure you're ready to draw a picture of what you're trying to do on the board, and that'll help guide you to a better solution. If you come to me without an idea, I will tell you to keep thinking about it. Please have an idea when you come to me. Give me something to start with, okay? Just something to start with. Keep in mind there are many good, fair, and absolutely terrible solutions to data structure projects. So, and the reason for this is if you come to me with an idea and I have to sit there and think about it, I just haven't seen that version before, or I haven't seen it presented in this way. So just give me some time, I'll think about it. That's just the way data structure is. It's actually one of the coolest aspects of this class is that I get to see different solutions, ones that I hadn't thought of before.
We get to test you.
Yes, exactly. You're actually testing me in a way. All right, future, make sure I cover this project a little more detail next class to make sure you know how to do certain things. I'm going to try and give you... Huh?
We'll pester you.
Thank you. I'll try and give you a couple more test cases to help out. Part of the grade will be how well you write test cases. I am actually going to test your test cases here, although I'm going to give you some of my own. One thing I completely didn't do, code names. I want to present the speed and memory results for this project. By CSU policy, I'm not allowed to display the names without explicit permission, so I don't want to do that. I don't want permission from all of y'all, blah, 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 blah. Yes?
What about, say if you wanted to give you, say if I wanted my name to be up there, is that okay? And
Yeah.
I tell you.
You can just tell me. I'm just going to, the way I'm going to do it, give me a code name, an alias. If you just want your name up there, sure, that's fine. If you want to be called something cool, Code Wizard, Wombat, Code Warrior, Elite Hacksaw, whatever,
Where did you get this code?
Darth.
email it to me. Yeah, if you can give me that code name, Eric, but I think if it has the word Darth, everyone's going to know who it is. just going to throw that out there.
Supposed to be an anonymous group.
It should be you can make it funny or whatever you want.
Has anyone actually given you anonymous?
Anonymous? That would be a good one. Email that to me so I know who to put up there. I mean, if your GitHub name is pretty anonymous, you could use that. Just whatever you want. Yeah, git add the same way. It's due February 9th, and that way we'll have time to get started on the next project. No teamwork. The work must be your own because it's all about you.
Yay.
About finding yourself.
About finding yourself.
Hardest part of this class.
I will admit that the first project has the worst grade out of all the projects. So fair warning. And I don't know if that's because this is the hardest one.
This is the hardest one?
I don't know if the reason for that is because this is the hardest one or it's because students are trying to get adjusted to how projects
Yeah.
work in this class.
Probably the second one.
So,
I would say
No, that's the
Anagram
first
Maker is
one.
the hardest one.
Anagram Maker was pretty hard.
Anagram Maker is like impossibly hard.
Oh, Anagram Maker is awesome. But we're not going to be doing that this semester.
Oh,
No, we can't. Yeah, that one's been used up.
good.
All right, any questions? Comments?
Concerns.
Concerns? Screams of angst? Help me. Help me. All right, great. And I finished just in time. So that's it for the project. You now have an hour of lap time. Use it wisely. I will now help you, Craig.